So today we're just talking about the normal distribution and using what's called the empirical rule to analyze normally distributed data. Tomorrow we will be using graphing calculators to find probabilities in a standard normal distribution, so talking about how that compares to just a regular normal distribution. And Thursday I actually will not be here, but you will have a work day to practice what we do tomorrow with the graphing calculator. Since many of you don't own a graphing calculator, any practice you do would have to be in class, so that practice will be on Thursday. And the sub that will be here is a former math teacher, so she would be able to help if you even had trouble with the graphing calculators or understanding what you're trying to find. She should be able to help you with that. And then Friday we start reviewing for the test. Test is next week, Tuesday, so that's what's coming up. So for a normal distribution, I just have some information before we actually get into examples. But as it says at the top, we have distributions shown here of mileages of different sample sizes of cars. So we have a sample size of 100 cars, 10,000 cars, and then an entire population of cars. So notice as the sample size increases, the distributions become more and more symmetric, and therefore they resemble the curve at the right due to the law of large numbers. So that says as you increase your sample size, you will have a symmetric, normally distributed set of data. So the curve at the right, so this curve right here is a normal distribution. And what a normal distribution is, it's a continuous, symmetric, bell-shaped distribution of a random variable. It's the most common probability distribution and has the following characteristics. The first one we've already talked about. It's continuous, bell-shaped, symmetric with respect to the mean. The mean, median, and mode are all equal, and they're located at the center. So if you look at this distribution that's given here, this 24 would be the mean. So mean, median, and mode are all equal in a normal distribution. They're directly at the center. The curve approaches but never touches the x-axis. So when it's drawn, this line, horizontal line that you see would be representing the x-axis. And so the ends of, or either end of the curve, they're never touching, never crossing that x-axis. They're just approaching it. And the total area under the curve is equal to 1 or 100%. So this I'm going to highlight because when you calculate probabilities, what I want you to realize, or rather what I want you to connect in your mind, is the area that is under a probability curve like this, or rather the area that's under the curve that's shaded in is representing the probability. So if you're looking at a visual representation of probability, it would be the area that's shaded in. So you'll kind of notice when we go through examples, if I'm shading things in, that's the probability that you're estimating. And then we have actually what I just said. Area under the normal curve represents the amount of data within a certain interval, or the probability that a random data falls within that interval. This is just something that is important for you to understand. Area under the curve is the amount of data, or the probability that a random data value will fall within that interval. And that's why the total area under the curve is equal to 1 or 100%. So the empirical rule, this can be used to determine area or probability under a normal curve at specific intervals. So empirical rule, so in a normal distribution with mean represented by mu, because we're talking about a population, and standard deviation is represented with sigma. Looks like an O, it's the Greek S, sigma. And I'm going to actually, I'll point things out on this diagram. I'm also going to have you cross things out because I don't want certain values on this chart to confuse you. I meant to white them out before I copied it, and then I did that. So approximately, it's another way to think of the empirical rule is the 68, 95, 99.7 rule. So it says approximately 68% of the data fall within, and this 1 sigma means 1 standard deviation of the mean. So we're going to actually be setting up, like labeling a normal distribution for a set of data, but you would label the mean right in the center. And then what you do is to go out 1 standard deviation, you add the standard deviation to the mean, get a value. You also go in the negative direction, subtract the standard deviation from the mean. So within that 1 standard deviation, that is 68% of your data. So any value, the probability any value would fall between those two values would be 68%. That would be the probability. Approximately 95% of the data fall within 2 standard deviations. So if you go out another standard deviation in either direction, that is representing 95% of the data. And then approximately 99.7% of the data fall within 3 standard deviations. So you're going out another standard deviation in either direction, that's 99.7. So on here, you could probably leave these 34% filled in. This should make sense because if within 1 standard deviation, that's 68%, if you divide 68 in half, you get 34. I would recommend just crossing these values out because I don't want those to confuse you, and typically those values are never your answer to any question. So I'd rather you just understand the 68, 95, and 99.7. As long as you know those 3 values, you should be able to calculate any other probabilities that you need for a normally distributed set of data. So if you look at example 1, it says a normal distribution has a mean of 45.1 and a standard deviation of 9.6. And part A says find the values that represent the middle 99.7% of the distribution, and part B says what percent of the data will be greater than 54.7. So what I'm first going to do is, based on the mean and the standard deviation, I'm going to label my x-axis. So again, your mean of 45.1, that goes directly in the center. So directly in the center, I'm just going to label that as 45.1. And then here you may need a calculator. So now to continue labeling this, you need the standard deviation, which is 9.6. So that next line, I'm going to work to the right first. I would take the mean of 45.1, and I'm going to add 9.6. I'm going to add 1 standard deviation, that's 54.7. So the first line to the right of the mean is 54.7. And then I'm going to keep going in the right. I'm going to add another 9.6. So 2 standard deviations away is 64.3. And then I'm going to go 1 more, add another 9.6. 3 standard deviations away is 73.9. Okay, so you start with your mean, and then you keep adding the value of the standard deviation until you get 3 away. Then I go in the other direction. So I'm going to do 45.1, the mean, and subtract 9.6, subtract the standard deviation. So to the left of the mean, that first value is 35.5. Subtract the standard deviation again. So 2 standard deviations away is 25.9. And then subtract it 1 more time, 16.3. Okay, so again, not difficult to fill that in. You just have to know what numbers go where, what numbers to use to calculate, to find all of those values. Once you have that set up, now we can answer these questions. So it says, find the values that represent the middle 99.7% of the distribution. So 99.7, or rather, 99.7% of the data is within 3 standard deviations of your mean. So if I go out from the mean 3 standard deviations in either direction, so that would be the 16.3 and the 73.9, that is representing the middle 99.7% of my data. Between those values, I have 99.7% of my data. So I'm going to write it this way. These are all values of the random variable x, by the way. So I'm going to write that x should be in between 16.3 and 73.9. So x values between 16.3, 73.9 represent the middle 99.7% of the distribution. Okay, and then for part B, it says what percent of the data will be greater than 54.7. So I'm actually, for part B, since this is the last question, I'm actually going to shade on here what it's looking for. So I find 54.7 on my axis, and any value greater than that would be this area is what I'm looking for, this probability. Okay, so the answer to this question, I know I have the 68, 95, 99.7, but neither of those 3% are the answer to this question. I have to figure this out. So there's a few ways you can think through this. I'll explain one. Let me know if you have questions, but as you're working through problems, there's not just one right way to find these values. It's just problem solving. So I know from the mean in either direction, that is 50% of the data. So the mean divides that curve completely in half. So I know that the region I'm looking for is 50% minus whatever the percentage is here, which you could actually find from up here. I know that within one standard deviation, this is 68%. So I know these are both 34%, half of 68. So the value or the probability I'm looking for is going to be 50% of the data minus 34%, meaning what percent of the data is greater than 54.7? 16% of the data. Okay, so the 68, 95, 99.7 will not always be the answers to the questions you're asked, but knowing those three values should allow you to find any probability that you need if it's normally distributed. Okay, any questions on example 1? Okay, so what I would like you to do is, for example 2, I'll leave this just in case I know some people walking in might still be copying some things down. But I would like you to answer example 2 or try example 2 on your own or in your groups. So set up that x-axis, label your x-axis, you're given the mean and the standard deviation, and then try to find answers to parts A and B. Yes, remember within 3 standard deviations, that's not 100% of the data, it's only 99.7. So there is a very small percent of data that's less than 4.3 for part B. So and the way I did this one, that was one way to think through it. So it's just problem solving. So 4.3, normally what I think of is 4.3 is 3 standard deviations away. So I know that between these two numbers that are both 3 standard deviations away, that's 99.7. What am I subtracted by 34? Because the 34%. So what I would do is, I know the entire area I would subtract 100 and then because you have small after that side, we have to divide it. Because so 100 minus 99.7 but you have area on the side and on the side. So together they total. So you cut it in
Unless you ignore that the other side then I don't know how you figure it out.
This is right. You just want to make sure this 100 by 300 or you have to try that. So the total area under the entire and then because this number is deviations away,
Yeah, I want to
I would take 100 so you have to divide it in half.
my answers are all yeah. Not even out of the pack. Oh,
I have it right.
He's
Why? So, yeah.
Oh.
Don't talk to the pedestrian. Then he honks at me and then well, that's why I'm not gonna no, I thought you told me to start over tomorrow.
Well, because I'm not giving you these. I don't want you to memorize what these are. Because as long as you know 68, 95, 97, so what I would look at is, this is 3 standard deviations away generally. So within, or from 4.3 to 12.1, that's 99.7% of your data. You only want this part over here. So I would take, the whole curve is 100%, so I would take 100 minus 99.7, and then you're going to get 0.3. 0.3 is the area over here and over here add together to 0.3. And then you have to divide it in half to get this number. Does that make sense? Okay. I think we're at a point where we're all okay. So make sure you have the right answer. I know I checked in with all of you. Some of you came in late. I wanted to make sure you understood what was going on. As I said on the front, as long as you know the 68, 95, 99.7, you should be able to calculate any other probability if it's normally distributed. So I know some of you are working ahead for examples 3 and 4, so if you were, just make sure the answers you got are correct. There's something slightly different about how some of these questions are asked and how you have to answer them. So for example 3, it says students counted the number of candies in 100 small packages. I need your attention back up here, please. They found that the number of candies per package was normally distributed with a mean of 23 candies per package and a standard deviation of 1 piece of candy. So it says about how many packages have between 22 and 24 candies. So I'm going to set up or label my curve. So my mean is 23 and standard deviation is 1. So I need to keep going up 1 and down 1 to label this. Okay, so your entire range of values should be between 20 and 26. So it says about how many packages have between 22 and 24. This question is asking you for a number of packages. It is not asking you for a probability. So your answer should be a number of packages. It should not be a percent. So first of all, if we look at our curve between 22 and 24, what percent of our data is that? 68. So it's within 1 standard deviation on either side, 68%. So between 22 and 24 candies is 68%. 68% is not your answer though. It says about how many packages. Therefore, since they are using 100 small packages, I need to find what 68% of 100 is. Okay, it is 68. I know, maybe this is a poor example, but the 68% is not the answer. So then you have to take 68% of 100, which does end up being 68. So make sure when you read the questions, ask yourself, is it asking me for a percent as an answer, or am I supposed to be giving a value with a specific unit? And then part B says, what is the probability? So this is actually asking for probability. Your answer should be a percent. What is the probability that a package selected at random has more than 25 candies? So it's asking for this area here. Ideas on how we could figure that out? Cora? Yes, you could certainly do it that way. So 25 is 2 standard deviations away, meaning between 21 and 25, that's 95%. So you could take 100% and subtract 95%, and that gives you 5%. But then we need to divide that in half to just get the upper part of that. So these two ends total 5%. Divide that in 2, so it would be 2.5%. And that did ask for a probability, so the percent is your answer. Okay, any questions on that one? Okay, so I want you, if you haven't already, work through example 4. If you have, just double check that you answered the questions correctly. You're giving percents when they ask for them, units when they ask for them. And then I will, when I come around, I can check, answer questions, and I'll also pass out the assignment.
I don't know. No, so you
I would go off of
how do you do that?
So
Well, I marked it 95 and I was just give me 2.5.
This is 95%. Well, this and this are 5%, so this is half of 5%. Rather than subtracting something from 100, you could do 95 plus 2. I would accept 2. Yes, you have the right word, but your degree is not right. 97. Okay, that's good. I think, well, actually, some of you at the beginning didn't have everything answered when I walked around, so double check what you have. And I would accept, so for part A, because you're talking about members, a number of people, do not leave 557.6. Round that to a whole person. I would accept 558 or 557 if we rounded it down because it is not quite 558, so I would accept either one. And then part B, if you didn't have it answered when I walk around, you have questions on that, please make sure you let me know. We do still have 9 minutes left of class, so there's no reason this should be put away, or if you even want to work on past assignments, if you have questions for what would be on your homework quiz tomorrow, you could ask that right now.